All right. Let's go ahead and review some things we talked about yesterday. We started a new chapter yesterday, and where in chapter 11 we had looked briefly at how many possibilities exist in an uncertain situation, which we call class counting. In chapter 11 we're talking about the likelihood that a particular event takes place. So the two ideas are very closely connected, obviously. But what do we call the likelihood that an uncertain or a particular event occurs in an uncertain situation, Audrey? Probability. And probability is typically going to be expressed in a couple of different ways. How do we normally write probabilities? Maddie? Okay, that's actually the formula for probability. That was going to be my next question, but it leads to the answer anyway, so we'll go with it. It's the number of desired outcomes, things you want to happen, over the number of possible outcomes that could happen. And so because of this, because probability is this compared to this, we say that probability is typically expressed, anyone, as a ratio, most commonly. Now, ratios can be turned into decimals in some cases. The book likes to do that. I personally hate that approach because people look at it like, they don't know what that means. They know what a ratio means. They know what what's another way to show a fraction or decimal? Percent. There we go. So typically as a ratio or as a percent, but it does start always as a ratio, number of desired outcomes to number of possible outcomes. That's in an uncertain situation in which all possibilities are equally likely. But there are times where different possibilities aren't equally likely. For instance, if I step up to the plate in a baseball game, I could get hit by the pitch. I could strike out. That's pretty highly likely. I could foul out or fly out. I could line out. I could ground out. I could be thrown out. I could get a single, could get a double, could get a triple. We're getting more unlikely. Could get a home run. Could get walked. That would actually be my goal if I came to the plate in Major League. But just walk me. Crowd the plate. Saw this one guy, I think it was for isn't there like a Bananas baseball team somewhere in the air? Anyway, I think the one guy went down to a full split in the batter's box, which just sounds painful, but of course his strike zone is now this small, and it's right above the plate where it's really hard. So anyway, the pitcher, I think, walked him. But anyway, there's all these different possibilities, but they're not equally likely, are they? Hitting a home run is not as likely as striking out. Right? Because there's, a certain knowledge of my limitations. There's a certain, maybe a past history in some instances, though I've not got past history in the major leagues, but I have reason to believe based on past history at lower levels that major leagues would not work out so good. But anyway, what do we call probability based on past history or based on prior knowledge that affects the outcomes? Kendall? It's a form of probability, but it's not exactly the same. Anyone? Relative frequency. Frequency meaning frequently things happen. Relative meaning compared to how many times there's been a chance for it to happen. Now, of course, I have had 0 opportunities to hit a home run in a major league game, and hence I've hit 0. I'm sure if I were given opportunities, I still would hit one. But anyway, relative frequency. And so it's a very similar equation for probability, but instead of number of desired outcomes, number of successful outcomes, meaning successful in the past, right? And instead of number of possible outcomes, we would have number of total opportunities in the past. Very similar. Instead of desired to possibilities, it's successful to total. Both of them forms of probability. We said there are a few rules for probability. First of all, probability cannot be greater than 1 or 100%. Probability cannot be lower than 0 or 0%. Probability's got to be somewhere in that range of values. Also, if we took all the different probabilities in an uncertain situation, the probabilities have to add up to 1. They must add up to 1. Take all the possibilities that exist, they have to add up to a 100% possibility. What would we call a 100% possibility? Certain. How about a 0% possibility?
Negative.
Impossible. So those aren't actual terms you have to know in your notes. We did say this, though, that if we have, for instance, let's say there's a 3 to 5 chance, that's a pretty good chance, a 3 to 5 chance that that it rains later today. It's not, but maybe tomorrow there is. Tomorrow there's a 3 to 5 chance that it rains. Well, then what's the chance it does not rain? 2 to 5, right? We call the probability that something doesn't happen the complement. The complement, you should have that term in your notes. And we notate the complement of a situation. For instance, if it's the possibility of event A, or maybe let's go with the possibility of rain. Well, the possibility of rain is P rain. The probability of event A happening is P, and then in parentheses A. The complement is notated with what appears to be an exponent of C. It looks like an exponent. It's not a power or anything like that. It just means the complement. How do I find the complement of any event? For instance, I said 3 to 5 chance of rain tomorrow, which means 2 to 5 chance it doesn't, because how do I get that? Subtract from 1. 1 is certainty minus the probability that something does happen gives us the probability that it does not happen. Yesterday in your notes, I believe we started to get compound probability. Check your notes. Do you find compound probability? And this, remember I told you, gives you the possibility that a couple of things happen. The probability of A or B happening. Where, I'll be happy with A or I'll be happy with B. Either one of those would be really good. And I believe, did I give you the formula for it yet? We finished up the probability of A plus, that's key, the probability of B. Around here, I want you to write or equals add. Or equals add. You add probabilities together when they're joined by the word or. And I believe I left off with talking about this if these two things, A and B, are mutually exclusive. Did I have you write this part yet? I'm trying to remember where I left off yesterday. Okay, so we got there. So the idea of mutually exclusive, for instance, let's suppose I have a, a set of balls to play with for kids or something, and I've got 3 red balls, I've got 5 blue balls, I've got 7 yellow balls in the bag, and you just reach in, they're all the same size, they all feel the same, so it's not like, oh, the tennis ball is yellow and the whatever, but they all feel the same. You just reach in, pull a ball out at random. Well, the probability of a red ball class would be 3 to 15, because you're going to the total number of possible outcomes that exist. There are 15 possible balls that could be pulled out. 3 of them are red. So the probability of red would be 3 to 15. But if I said the probability of red or blue, well, then I would take the probability of red and I would add the probability of blue. What's the odds of blue class? 5 to 15. By the way, notice I don't want to necessarily reduce these down to 1 to 5 and 1 to 3, because if you're going to add them, you want that common denominator. Class, what's the probability of a red ball or a blue ball? 8 to 15. You simply add them together. Because, here's the key, that which is red is not blue. Right? What would the odds are I get a red one? I feel there's not a whole lot of red ones in here. Pull out a blue ball. Yes, it's red! It's not, right? There's people in society who struggle with this, by the way, on a semi-serious note. It's not with red and blue, but it's with some other more important things. But I'll leave it there. Red, that which is red is not blue. They're not the same thing. But let's suppose, Genesis, she just figured out what I was talking about. It's pretty pathetic, isn't it? It's just about that pathetic. All right, let's suppose that the balls were numbered 1, 2, and 3. Suppose the blue balls were numbered 1, 2, 3, 4, 5. Suppose the yellow balls were numbered 1 through 7. Well, let's suppose I said, what's the probability that I pull out a blue ball or I pull out a 2? Well, how many blue balls are there, class? 5 out of 15. Plus, because or means we add, what's the probability we pull out a 2? 3. There's a red 2, a blue 2, and a yellow 2, right? So there's a 3 out of 15 chance I pull out a 2. But you realize a ball can be blue and 2 at the same time. You see that? Blue and 2 are not mutually exclusive. So if not mutually exclusive, I'm going to abbreviate here. what we'll have to do is take the probability of the first plus the probability of the second, but we have to subtract the probability that both occur. The probability that both could occur at the same time. I like to refer to this right here as the overlap. That which falls into both categories. We have to subtract away the overlap. Otherwise, we're counting the same ball twice. My blue 2 ball just got counted in both categories, but it's not 2 separate balls. It's one ball that happens to be blue and it happens to have a number 2 on it. So we'll subtract that one overlapping ball away. What's the probability that I either draw a blue or a 2 class? 7 to 15. We still add the possibilities of blue and 2, but we would have to subtract the overlap if they're not mutually exclusive. Does that make sense? Questions on this? All right, I have a handout for you, which we're going to, actually, we don't have time to work the handout, so never mind. We'll save the handout for next lesson. Your homework for this evening, and I was hoping to practice this before. We got a little bit of time cut short, if you're watching, because chapel went long, lunch went long, so lost a little bit of time here that we were supposed to have time to get a handout done. Instead, for homework, page 503, 503 to 504, page 503 to 504, numbers 32 to 40, and the even. Also, going over the homework, which took a lot longer earlier at the start of the hour because we hadn't done it yet. Anyway, page 503 to 504, 32 to 40, the even. Do your best with them. If you feel totally clueless and lost, don't worry. By the time we're done with Monday, you'll understand what's going on. But I think with the instruction you've got, you should have at least a fighting chance on 32 to 40, the even. And again, all of this, I believe, is stuff you talked about in junior high, but it's been a few years. So good review for us here. All right, have a wonderful rest of the day. Have a great weekend, and we'll continue probability next week.